Hello student, how are you? I think all of you are fine and all of you are studying properly. Today I am going to discuss the next part of this chapter set, and this is the third lecture of this chapter. So without wasting any time, I am going to discuss what is actually in next part. First one is actually in next part. First portion is actually Venn diagram. What is Venn diagram? Venn diagram, it is actually a pictorial representation. It is actually Venn diagram is actually a pictorial representation of set operation. In ancient time, mathematician used to represent set operations within a closed curve, and at that time this method was popular, and at that time universal set was represented within a closed curve like that, and any subset of this universal set was represented by points within this closed curve. And this method first and this idea first gave Leonhard Euler, that means our mathematician Euler, and but later British mathematician John Venn discovered another method, and according to this John Venn, this method is known as actually Venn diagram, or this pictorial representation is known as Venn diagram. And this Venn diagram is also popular by Venn Euler diagram also, or commonly Venn diagram. And first one is our respected Leonhard Euler sir, and second one is John Venn sir. And in Venn diagram, how can we represent? In Venn diagram, first universal set is represented by a rectangle, and here the rectangle, it is represented, it actually represents the universal set, and here A and B are two of its subset. That means in Venn diagram, any universal set is represented by rectangle, and any of its subset is represented either by circle or by oval shape. Oval, that means elliptical set, elliptical. So we can represent in this way also. Suppose A and B are two of its subset, then it can be represented by in this way also, where U represent universal set, and sometimes instead of U, S is also used. Okay, next is next we need to learn actually operation defined on set, and there are 6 different types of operation. First one is union of set, second one is intersection of set, third one disjoint of set, third one fourth one is actually difference of set, fifth one is actually symmetric difference of two sets, and sixth one is actually complement of a set. Now what is union of two set? Say suppose A and B are two set, then the union of A and B is actually a set, and it is represented by A union B. We use this notation to define union of two set, and it is read as A union B. And if you want to represent it by property method, it will be like that, that A union B equal to X such that X belongs to A or X belongs to B, and this is the symbol of OR. And here this is the representation of A union B by property method. If we consider two example of roster method, then it will be more clear. So let A equal to 1, 2 and 3 and B equal to 4, 5 and 6, then A union B, it will be 1, 2, 3, 4, 5 and 6. And if we consider the corresponding Venn diagram, then it will be like that, that here U is the rectangle represent the universal set U, and A is a subset of U, B is also a subset of U, and here this region actually represent A union B. Next operation is actually intersection of two set. So what is intersection of two set? Say suppose A and B be two set. The intersection of A and B, it is also a set, and it is denoted by the symbol A intersection B. That means this one, A intersection B, and it is read as A intersection B. And if we want to represent A intersection B by property method, it will be like that, that X says that X belongs to A, and this is the symbol of and X belongs to A and X belongs to B. So this is actually the property representation. Now if we consider an example of this intersection by roster method, it will be more clear. And say suppose A equal to 1, 2, 3, B equal to 3, 4, 5, then A intersection B, it will be A intersection B will be A intersection B will be actually 3, and by Venn diagram we can represent it, and it will be like that, A intersection B is actually this region here, this one, this is the region of A intersection B. That means see here, so A intersection B is actually the set, or A intersection B actually the set which contains all those elements which lies both in A and in B. Now next operation is disjoint set. What is disjoint set? Say for any two set A and B, if A intersection B equal to 5, then two set A and B are said to be disjoint set, and if A intersection B not equal to 5, then A and B are said to be intersecting or overlapping set. And if we consider the respective Venn diagram, then it will be like that, that here the whole rectangle represent the universal set U, and A and B are two of its subset, so A is a subset of U and B is a subset of U. And see here, there is no common region between A and B, so here there is no common region between A and B, so A and B are disjoint set. Now next operation is difference of two set. Say for any two set A and B, the difference of A and B is actually denoted by A minus B, and A minus B is actually a set which contains all those elements which are actually only in A but not in B. And if we want to express this by property method, then it will be like that, that x such that x belongs to A and x does not belongs to B. Similarly, we can calculate the difference between B and A, and it will be like that, B minus A will be x such that x belongs to B and x does not belongs to A. That means B minus A is also a set, and B minus A contains all those elements which are only in B but not in A. And if we consider an example of roster method, then it will be like that. Say let A equal to 1, 2, 3, 4, and B equal to 3, 4, 5 and 6. Then A minus B will be 1, 2, since 1, 2 present only in A but not in B. Similarly, if we consider B minus A, then it will be like that, 5 and 6 are present only in B but not in A, so B minus A will be actually 5, 6. And here I have given a Venn diagram of A minus B, and it will be this one, this region, A minus B. And similarly, if we can write this one, the corresponding Venn diagram of B minus A, and it will be like that. So suppose this is A and this is B, this one is A and this one is B, so this portion is actually represent B minus A. Now next operation is symmetric difference of two set. What is symmetric difference of two set? Symmetric difference of two set is actually denoted by A del B, and A del B is actually a set which is union of A minus B and B minus A. And we have just read these two operation, A minus B and B minus A, in difference of two set, and we can write this by property method. And if we write it by property method, it will be like that, that x such that x belongs to A intersection B, x belongs to A, x does not belongs to A intersection B. Say if we consider an example by roster method, it say let A equal to 1, 2, 3 and B equal to 4, 5, 6. So in this case A minus B will be 1, 2, 3 and B minus A, it will be 4, 5, 6. And if we calculate union of A minus B and B minus A, it will be 1, 2, 3, 4, 5 and 6, and it will be actually A del B. And A del B by Venn diagram, it is represented like that, A del B is actually this region marked by the black line. Now next operation is actually complement of a set, and complement of a set is actually one operation, another so complement of a set, for any set A, complement of A is denoted by A complement, or we can denote it by A prime or A bar also, and it is actually and it is actually defined all those elements which are not in A. That means which are actually not in A. So in Venn diagram, suppose let U equal to first 10 natural number 1 2 3 4 5 6 7 8 9, first 9 natural number, and A equal to 1 2 3 4 and 5. So A complement will be U minus A. U minus A means all those elements which are only in A but not in U but not in A. So here clearly here 6 7 8 9, these are only in 6 7 8 9, these are only in U but not in A. So A complement will be 6 7 8 and 9. Okay, so next we need to learn actually laws of algebra. There are actually 6 laws of algebra of sets, and among these 6 laws, and these are actually associative laws, commutative laws, identity laws, idempotent laws, distributive laws, and De Morgan's laws. And these 5 we have already read. Actually these 5 laws actually we have read in algebra of number system, but the 6th one, this is actually very very important for set. Not only set, it is important for physics also. In logic gates, this De Morgan's law is very much used, and discrete mathematics also. So not only in so first it is used in logic gates in physics, and second one in discrete mathematics. Now what is actually associative laws? So for any 3 set A B C, A union B union C equal to A union B union C. Similarly, if we consider on basis of intersection, it will be like that: A intersection B intersection C equal to A intersection B intersection C. That means both union and intersection both are associative. Similarly, commutative laws. What is commutative laws? So for any 2 sets A and B, A union B equal to B union A, and similarly A intersection B equal to B intersection A. That means both union and our intersection both are commutative. Okay, next one is identity laws. What is identity laws? And we have, it is almost similar of algebraic identities laws. In algebraic identities laws, we have read actually there are 2 identity elements. Here phi and u are actually behaves this identity elements, behaves like that identity elements. So A union phi equal to A and A intersection u equal to A, and that's why here phi and u are the respective identity elements for one is for union and another is for intersection. Next one is idempotent laws. Idempotent laws actually we have read in matrix algebra. What is idempotent laws? For any set A union A equal to A and A intersection A equal to also A. So these laws are actually almost similar, no problem, and so I think all of you can easily understand this one. And next one is distributive laws. What is distributive laws? So for any 3 sets A, B, C, A union B intersection C equal to A union B intersection A union C, and similarly A intersection B union C equal to A intersection B union A intersection C. And here, that means here first union is distributive over intersection, and second intersection is also distributive on union. That means union and intersection are distributive over intersection and union respectively. And next, the most important law, which is De Morgan's law. So what is De Morgan's law? For any two sets A and B, A union B whole complement equal to A complement intersection B complement. And that means if we consider complement of union of any two sets, it is equal to the intersection of their individual complement. It is actually this one complement of A, complement of B, and this equal to their intersection of their individual complement. And similarly, if we consider complement of intersection, then it is actually equal to complement of their union of their individual complement. And okay, and the next one is some two important result. There are a lot of important result, but here we need only these two, first one and third one, and these are generally used to find the number of elements, and we can prove this result by Venn diagram. So first one is for a number of elements of any two set A, that means A union B, it is equal to NA plus NB minus N intersection B. That means number of elements present in A, number of elements present in B minus number of elements present in A intersection B. Similarly, number of elements present in A union B, it is actually equal to number of elements present in A. If A and B are disjoint set, then in this case A intersection B, in this case N of A intersection B, it will be 5, and in this case N of A union B equal to NA plus NB. Similarly, if we consider three sets N of A union B union C, it will be NA, that means number of elements present in A, number of elements present in B, number of elements present in C, minus number of elements present in A intersection B, minus number of elements present in B intersection C, and number of elements present in C intersection A, plus number of elements present in A intersection B intersection C. So when we will solve problem, we will use number 1 and number 3. So we need to remember this number 1 and number 2, and today we have read this one, operation defined on set and algebra, laws of algebra. We need to remember this one also. And so thanks for watching, and if anyone have any queries, they can message me in WhatsApp, or they can write in comment section. And please subscribe our channel Unique Science Zone, and like, share and comment in our videos. And thank you once again, and thanks for watching.